Okay, today we are going to learn about the solution of the homogeneous equation for the linear system. So if you take a look at the set of equations here, you said that we have like n equation. Okay, and each term we have the first derivative of the y1, y2, and to yn. Okay, the way to find the answer of this linear system, we can do it by first we writing it in the term of matrix form, which is this, and then we assume that y1 is equal to k1 times exponential of lambda t. y2 is equal to k2 times exponential of lambda t, and yn is kn times the exponential of lambda t. So from this one, if we know the lambda, then we would know the answer of this linear system. So if whatever we assume is correct, when we plug each y in our differential equation, it should make this equation satisfied. Okay. So the way that we are going to do next is just that plug each y term back into our differential equation. So if you take a look at our first differential equation, we have the first derivative of y1 by dt. And now our y1 is equal to k1 times exponential of lambda t. So you do derivative of this y1, you would get k1, k2, k3 until kn are constant. So the first derivative of y1 is equal to k1 times lambda times exponential of lambda t. So our first equation we can write down like this: k1 times lambda times exponential of lambda t equal to a11 k1 times exponential of lambda t plus a12 k2 times exponential of lambda t, and then the nth term is a1n times kn times exponential of lambda t. We do the same thing for our second equation. So the first derivative of y2 equal to k2 times lambda times exponential of lambda t. Right? And then we just plug it into our second equation. So we would get k2 lambda times exponential of lambda t equal to a11 k1 exponential of lambda t plus a22 k2 times exponential of lambda t plus the nth term is a2n kn exponential of lambda t. And we do the same until the nth equation, that we would get kn lambda exponential of lambda t is equal to this is 2, 1, 2, 2, 2n. This is an 1 n2, and the nth term is ann kn. I'm going to move or the term here to the same side. Okay, so I move this one to there, I would get a11 minus lambda times k1 a1n kn equal to 0. Right? This is our first equation. And then our second equation, you would get a to 2 minus lambda. This one is k1. This is k2, a2n, and our last term a what? an1. This is what? This is a21, right? Not 1, 2. This is a21. a1n, k1, an2, k2, and the last term is a2n minus lambda kn. Every equation in here has the term of exponential of lambda t. So I said that, okay, divide every equation with exponential of lambda t. From that, I would get a11 minus lambda k1 1n kn, a21 k1 plus a22 minus lambda k2 a2n kn. And then the end, our end equation is a n1 k1 plus a n2 k2 plus the last term is a n minus lambda kn. From this one, we can write out in the term of matrix, so we would get so in order to make this sentence correct, we said that determinants of a minus lambda I could be 0 or k should be 0. But if our k is equal to 0, so we would get the trivial solution. So it shouldn't be. So the only thing that could make us get the equation got to be setting the determinants of a minus lambda I equal to 0, and this is called characteristic equation again. So that means we are going to find the lambda. Lambda we call eigenvalue. Eigenvalue. Someone may use to learn in the matrix or vector. You would hear this word before. Okay, so lambda is our eigenvalue. So if we know the lambda, then we would know the answer of this differential equation. So we are going to divide the value of lambda into 3 cases. Okay, and case 1 is lambda is a real number. I would say it's a unrepeated real number. Unrepeated real number. Okay. So if we have lambda 1, lambda 2, and lambda n are the solution of this equation, our characteristic equation, and lambda 1, lambda 2, and 2 lambda n are real number and they are not repeated. So then we would know that, okay, our y1 is equal to k1i times exponential of lambda 1t, and y2 is equal to k2 I times exponential of lambda 2t, and yn is equal to kn I times exponential of lambda nt. So the solution of the linear system are is equal to C1, K11, K1, K21, Kn1 times y1, which is exponential of lambda 1t plus c2, this is the lambda 2, k12, k22, kn2 times exponential of lambda 2t, and the last term is Cn, k1n, k2n till knn times exponential of lambda nt. That would be the answer of our homogeneous differential equation when it comes at the linear system.